All right, welcome back. This is a lightning review for lecture 2. We're going to review non-deterministic finite automata. And the relevant textbook material for this is CIPSR, pages 47 through 52. So an NFA is just like a DFA in that it reads in a string, character by character, and then it spits out a yes or a no answer. So it's still a math machine that reads in strings, and the set of strings it recognizes is still a language. However, it's got a couple extra powers. It can do things that the DFA can't do. In particular, it can transition on greater than or equal to one thing or less than one thing. I can read in a 0 and take 3 transition states or 10 transition states or 0 transition states. And because of that, I might have multiple live branches of computation. At a certain point in my computation, I might occupy multiple different states at the same time. So let's do an example of that. So I'm going to draw an NFA state diagram here. Like my DFA, I'll have a start state, which is going to be an accept state. I'll label it A. I'll add a couple more states, call them B and C. I'm going to add a special epsilon transition, which is new for NFAs. I'll explain it in a moment. And then I'll just go ahead and add some more edges here between these states. Note that I can be a little more careless when I do this now because I've relaxed the requirement that I have exactly one transition out on each alphabet symbol from each state. So if I try to leave a state on some character and there is no transition for that symbol, then my branch of computation will just die. Likewise, if there are multiple transitions, I will take both and my branch of computation will split. I'll have 2 live branches of computation in 2 different states. So let's run a couple test strings through this machine and kind of watch this happen. So for example, if I want to watch the evaluation of this NFA on the string 0, 1, 0. Just to make this clear, I'm going to draw a little table. And on the left, I'm going to put the characters we're reading in. And on the right, I'm going to list the live states, the states that our computation is in, the states that are being occupied. So I'll start at the very beginning. Our computation is just occupying state A. We've just started. And immediately before I even read in any characters, I'm going to take that epsilon edge. So epsilon, as usual, indicates our empty string. If you wanted to, you could think of it as just being like concatenating the empty string to the beginning of the string that we're evaluating this NFA on. We can imagine slipping in many empty strings wherever we want without changing the actual string. So that's sort of what we're doing on this epsilon. Whenever we take an epsilon transition, we stay where we started, but we also branch off a new computational branch. We follow the epsilon transition and end up in state C. Now we've already taken all the epsilon edges we can take. So it's time to read in our first character, the 0. Our first branch, the one that's in state A, dies because there's nowhere for it to go. However, our second branch in state C takes the 0 and ends up back in state A. From state A, we've got our epsilon transition again. So we're back in states A and C after taking our epsilon transition. Now it's time to read in the 1. Now it's the branch that's in state C that dies. There's no edge coming out of state C on a 1, but we do go from A to B here. From just B, there are no epsilon transitions to take. So we'll read in our 0. And this is the first time we'll see multiple transitions on one symbol. So when we read in that 0, our computational branch, our 1 live branch, will split in half. One will stay, follow that edge to stay in state B, and the other one will move to state C. There's no more epsilon edges to take. We've read in all the symbols. So at this point, our computation terminates. And with an NFA, we're going to accept if and only if at least one of our computational branches is in an accept state. Here, we do have two live branches, but neither one is in an accept state. So this string will reject. I'm going to do one more and go a little bit faster here. We'll read in 1010. And I'm going to move quickly. You can pause and redo it if you want. And you can test yourself by trying to predict what I'm going to do as I read in this string. So we start in state A. We take our epsilon transition and move to state AC as before. Now it's time to read in the 1. So branch in state C dies. Branch in state A goes to B. No epsilon transitions, so we read in the 0. The 0 branches to B and C. So now we're in states B and C, as we were at the end of the last execution. No epsilon transitions, so we then read in the next 1. The branch in state B dies. No, excuse me, the branch in state C dies. The branch in state B follows the transition and moves to state C. Finally, we read in a 0. We move from state C to state A. And now there's an epsilon edge we can take. So we end up finally in states A and C. At this point, we've read in all of our input characters. There are no more epsilon edges we can take. We're in states A and C. And because at least one of our live branches is in an accept state, is in state A, we accept. So that's our example of evaluating an NFA on some input strings. Before I end this video, I want to write down very quickly the formal definition of an NFA. So we've seen an NFA state diagram. For reference in CIPSR, it's on page 53. So an NFA, just like a DFA, is a 5-tuple that looks like this. Q, sigma, Q0, F, and delta. And what these things are, they're going to be very similar to their functions in a DFA. In fact, several of them are going to be identical. So Q will be a state set, like, for example, in our state diagram above, states are A, B, and C. Sigma is an alphabet. The alphabet above is 0, 1. Q0 is our start state. Above, that's the state A. F is our set of accept states. That's the set containing A. And then finally, delta is a transition. So it's the transition function, and it tells us if we are occupying a certain state, where do we go when we read in a character? And we'll actually end up evaluating delta multiple times for every step of computation, because if we're in multiple states, we'll want to look at where we go from each of those states. So delta will say, hey, give me a state Q, and also give me either an alphabet symbol, or if you want, give me the empty string. That's for an epsilon transition, and tell me where to go. The only difference here between this and a DFA is instead of going to a single state, we will go to a set of states. Remember, this curly P is the power set of Q. So this is the power set of Q is all subsets of Q, which is telling us we map from our state and our input to some subset of Q. That's all the states we end up in. So for example, in our previous state diagram, we might have delta if we're in state A and we see an epsilon, that'll say go to state C. Or if we're in state B and we see a 0, it'll tell us go to both state B and state C. So that's all for this lightning review of NFAs. Thanks for watching, and I will see you in class.